Hello, and once again, welcome to the maybe fourth class on atomic structure. Is it fourth class or fifth class?
Sir, fourth.
Fourth class.
Fourth.
So, we had seen in our last program that what Bohr was saying, that electron is a particle and is moving in a two-dimensional circular orbit. He didn't imagine about the wave nature of electron, but de Broglie proved with the help of Davison and Germer's experiment that electron is not merely a particle. Yes, it is a particle, but it is also a wave, and you can find its wavelength at different orbits. And in fact, all material particles, why electron inside an atom, but in even an electron gone, you are firing an electron gone, or cathode ray tube electron beam is coming out. So whenever a microscopic particle is moving with a high speed, it does exhibit wave motion, and you can experimentally prove that h by mv or h by 2 mek square root or 2 me into v square root, and we had done enough of proof of quantization of angular momentum. Also, we know how many full waves, standing waves are accommodated in different orbits. 2 pi r is equal to n lambda. All these things we know. And guys, those who are watching later, many guys are watching because I'm making a public video. Because I thought, if I'm recording, if some of my students sometimes might miss, even God forbid, one of you or both of you, sometimes if both of you, then we will stop the class. If there is some emergency situation, in there is a what like a school examination, something, so we can stop that class and we can postpone that class. But otherwise, if one is absent, we will have our class, and the recording will be there. So since there will be recording for even for two of you, we therefore we will have our program recorded, and that will be made public. So those who are watching later or in video, they might think of subscribing to my channel so that they can get the notification as soon as I produce. I also produce some other videos which are exactly not related to the course, but related to a science knowledge, which will help you in long run. Okay, then and today we shall be going one step ahead, two steps ahead, that electron is a wave, okay? But Heisenberg will now prove that electron wave is not confined to a particular radial distance. You know, it is existing in a three-dimensional space called orbital. So the concept of this is Heisenberg uncertainty principle. Heisenberg uncertainty principle, which we call hoop, that the orbit concept is changed to orbital. Orbital. Orbital is a 3D space surrounding the nucleus. In which the probability, now we cannot say certain, the probability or possibility of finding electron uh, having a particular energy is maximum, maybe more than 90%. 100% কেবে হবনি, more than 90%. So it's a three-dimensional space, not a fixed orbit. There it is exhibiting wave motion. This is, abstract. You cannot have any proof that is like a cloud, just you have a cloud over your head, but that cloud is showing wave motion. So now the concept that we will be following will be changing now. The hoop and then this Schrodinger's wave equation will be purely mathematical and abstract. One, and I forgot to tell you that de Broglie, when he introduced matter waves, and electron is a wave, he said, then hoop came, then the time of wave mechanics or quantum mechanics started. What we are doing now is wave mechanics. Quantum mechanics, the quantum theory is supreme, but mechanics, that term is talking about the probability aspect, the three-dimensional aspect, not a 2D track, but a three-dimensional aspect. So, wave mechanics, that it started with the idea of de Broglie matter waves and became more and more prominent and well defined by Heisenberg and followed by Schrodinger. So he proved the hoop is like this. The it is impossible. The definition is like this. It is impossible to measure both the position and momentum, means velocity, of a microscopic particle like electron precisely, simultaneously. There are two Lees, precisely and simultaneously. These variables are called canonically conjugate variables. Cannot be determined precisely simultaneously. And one canonically conjugate variables are, I have already mentioned, that is position and momentum. Momentum means velocity. Actual variable is velocity. Mass is constant. The rest mass is constant. I'm not talking about the relativistic mass, which changes with increase in velocity. And the other one is energy and time. These two are conjugate variables. So the first one is always given in the definition. But the second one you also have to know. Instead of writing here, it is impossible to measure both energy and time of a microscopic particle like electron precisely and simultaneously. So there will be always a degree of error. For example, the thought experiment goes like this. Who Heisenberg was more a mathematician than an experimentalist. So the thought experiment that he wanted to take the help to explain that supposing electron is going, it has some mass, however negligible it may be, it has a mass, and how you view. This is a thought experiment. You view, you have your eye. Supposing this is a microscope, this is a thought experiment, totally hypothetical. So this is supposing a very powerful microscope using some electromagnetic waves like visible, X-ray, whatever. So you are viewing an electron, and the principle is of viewing principle is a light photon will fall on a material particle. It will reflect by following the principle of reflection, or in this case there will be some effect which we will be talking about later, the Compton effect. That will not be discussing that now. But after reflection, the light photon will fall inside the microscope and come to your eye. Then only you can view. But this has a momentum. This photon, this is electron. As we have calculated, the photon is moving so fast with a speed of 3 times 10 to the power positive 8 meter per second. So fast, carries a large momentum, and the bombardment of this energetic photon with a microscopic particle like electron will definitely, there will be transfer of energy from photon to electron, and therefore the electron will not remain there. You will report because you are observing light has or any electromagnetic photon has already struck and reflected, and you will report that electron is here, but actually electron has moved a certain distance. So that distance, supposing, is del x. That del x is called the uncertainty or indeterminacy, menancy, or inaccuracy. Error, you can say error in position measurement. So since there will be transfer of energy, it will hit, and the electron will be having a different position than what it should have. Had there been no effect of the impact, then just like you are bowling a cricket ball, you are bowling, and you are somebody else is viewing it and measuring its position, so that you can calculate what is the velocity, what is the speed which the bowler is throwing. He can calculate very accurately, because a macroscopic particle like cricket ball or any bullet, it is we shall find that the error is almost zero. The error of measuring position and velocity will be almost zero. You can almost accurately find its position, where it is, and what is its velocity accurately by using a microscope, real microscope or any telescopic microscope, telescopic camera. You can, and nowadays, guys have started to image electron movement by using attosecond laser pulse. So, but there is some degree of error, some degree of inaccuracy, some degree of indeterminacy, also called uncertainty. That uncertainty term is little literary, but don't be swayed away with the literary meaning of uncertainty. It is nothing but the degree of error. So that is del x. Del x is the error in position measurement. It should have been here, but now it is being displaced because of the impact of the photon. And its velocity will also change. Supposing here the velocity it is going is v1, and after the impact its velocity changes to v2. So this change del v, which is v2 minus v1, is the uncertainty in or indeterminacy or error in velocity measurement. And if you multiply this del v by m, mass of the particle, m del v, that is the uncertainty or indeterminacy or error in momentum measurement. So he proved with a lot of his mathematical genius that the product of these two errors is nearly a constant, is greater than equal to. It may be more or at the most equal to h by, at that time, h by 2 pi. It was initially h, Planck's constant, then h by 2 pi. Now what you will be using is h by 4 pi. It was before it was h by h cross before, means h by 2 pi. But now it has been refined, the calculation has been refined later. Now for you, for solving problems, h by 4 pi. So that means if del x, if del x is small, tends to 0, you cannot make it 0. However sophisticated instrument you may use, still he proved by his mathematical skill that cannot be equal to 0. There will be some amount of uncertainty error, but that error might be very close to 0. If you do that, then del P will be very large. Del P or del V. Then del P or del V is very, very large. That means the position, the velocity measurement, velocity or momentum, same thing. The only difference is m, mass. Momentum measurement is totally erroneous. We cannot accept that data at all. Throw it to the dustbin. Because if del x tends to 0, it means position measurement is more or less accurate. Is more or less. We cannot say 100% accurate. It may be 98%, 99% accurate. So the first point is neither del x can be equal to 0, nor del p or del v can be equal to 0. It can tend to 0, very close to 0, but cannot be equal to 0. That is the first thing. The probability factor is always there. It may be 99.99% probable, but it's not 100%. However sophisticated instrument you may use for your measurements. But the second part is, if you buy any manipulation, if you decrease one, then the other one will increase. If you increase the other one will decrease, because the product will be always more or less equal to h by 4 pi, or it will be slightly more than that. So that is, you know, in the thought experiment, del x, I will tell you after some time. The other one is, if you can restrict the velocity measurement to more or less accurately, then that del p tends to zero. That means momentum measurement or velocity measurement is more or less accurate. So you rely on the data of velocity or momentum. Then at that time, del x will be extremely large, is very large. And at that time, the position measurement is extremely erroneous, is totally erroneous. You have to reject this data, position data. Since delta x is very large, the error is delta x. The error in velocity is del v. The error in momentum is del p. That is very small, close to zero. Then the velocity measurement can be relied upon, can be dependable. You can use that data because you have made the degree of error del x to be del p to be very, very small or very close to zero. Cannot be equal to zero. And therefore, we to prove that, Heisenberg made another thought experiment. He applied the principle of wave optics. That the principle of wave optics says that the uncertainty in position is roughly equal to the lambda of the photon. Roughly equal to the lambda of the photon. If you are using X-ray photon, microwave photon, X-ray photon, UV photon, then which are very small wavelength. So supposing you are using X-ray photon to view electron, X-ray microscope you are using. So since lambda is small, del x is small. In that case, del p and hence del v will be large, will be very, very large. And he explained this because lambda is small, the energy is high. If lambda is small for X-rays, then the energy will be very high. So the photon has so much energy when it impacts, hits, it transfers more energy. So the velocity changes very large, and therefore del P is very large. So the velocity measurement is highly erroneous. On the other hand, if microwave or radio waves, let's say radio wave, at his time radio waves were not known. If radio waves or microwave, he talked about microwave having large lambda. This is small lambda, large e. This is large lambda. Can you remind me what is the range of wavelength in microwave region? Maybe 6 into 10 to the
So,
power 6 to 6 into 10 to the power 9. Am I correct?
yes, sir.
Yes, sir.
So since lambda is large, energy is small. So it will hit, it will hit like a mm, rubber cork, like a solo, like a cotton tula. So because it carries less energy, so it cannot transfer more energy. So velocity measurement, the del v will be very small since del x, since del x is large because del x is roughly equal to lambda. If lambda is large, then is large. That means position measurement se ghunchi jibo, dhire kiri ghunchi jibo alga jaga ko, kintu velocity change almost hoboni. In that case, del p or del v will be small. That can be explained since it carries small energy, it will transfer very small. Nijor to kichi rakhibo na, kichi energy chhadibo, dabo. That will transfer very little energy to the electron with which it will impact. Because one is a photon, that is a hypothetical particle, but the other one is electron, which is a real particle, but both are waves. Photon is a wave, is a real wave, and this is I cannot say duplicate wave, it is also showing wave motion. That has been proved. So therefore, if one is restricted by something, by using X-ray, you restrict del X to be very close to zero because lambda is small, then you can rely upon the velocity, sorry, the position. You cannot rely on the velocity or momentum because del P will be very large, with large energy transfer. So the velocity change will be very high. Del V and or del P will be very large. So if del P is large, then momentum measurement will be highly erroneous. And the other way is using microwave or radio wave having large lambda. Large lambda means large delta x. Means the position measurement will be highly erroneous. In that case, del P will be very small and you can rely on the momentum or velocity measurement. Are you okay? Do you understand?
Yes, sir.
Yes, sir.
Okay, then let's solve some problem. I will show you. Then we'll go to the Heisenberg Uncertainty Principle. Now, I remind both of you to remind me 2 minutes before 6 to stop recording for some time so that there will be a continuity in the recording. Those who will be watching later will not feel monotonous. So I will be breaking for 2 to 3 minutes, maybe max 5 minutes. Will not stop the program and restart, but we will stop recording because it's not a live program. I'm recording in my computer and then I'm publishing it, uploading it later. So you continue with your uh, your Zoom. Don't disconnect. I'll be coming. I have an important work at 6. Remind me because I may forget. Now, I will give you some problem to solve. And also, you can write down also in the similar manner, del E into del T is less than, greater than equal to h by 4 pi. You write down that, where del E is the error in energy measurement, del T is the error in time measurement. I will tell you the implications if after some time. How you use this equation in solving problems. Del E is the error. Don't write so many things. Uncertainty, indeterminacy, error in energy measurement, and del T is the error in time measurement. So these two are canonically conjugate. Means gote badile gote kamibo. Del x badile del p kamibo, del x kamile del p body. So and the product will be always more or less equal to a constant h by 4 pi. And agru thila h cross, then h cross by 2 ହେଇଗଲା ପରବର୍ତ୍ତୀ କାଳରେ. H cross by 2 means h by 4 pi. Well, if one error approaches 0, cannot be 0, then other error becomes unacceptably large. Unacceptably large. So whatever, and del x definitely gote badhile gote kamibo, they are inversely related. We have all discussed that. Macroscopic particle Just like de Broglie matter wave doesn't carry any real meaning, similarly, for macroscopic particle, this hoop has no meaning. Only you will solve the problem, then you will find then both the errors are negligibly small. There, hoop is not applicable. Del x can be made equal to 0. At the same time, del p can be made equal to 0. It's not microscopic particle. By instrumental technique, now you can measure the exact velocity of a moving bullet, because you are using some pulse nowadays, powerful pulse to locate the electron at a particular position. And so both position measurement and velocity and or momentum measurement are accurate for macroscopic particle. Now, this is the thought experiment I told you, that after the impact of the photon, it will be displaced with a change in velocity and position. We have already done that. So, the thought experiment already I have told you. Then the concept of orbital, that there is no orbit concept was rejected. That could not be rejected after de Broglie. De Broglie only told it is executing wave motion, but I'm sorry, Heisenberg said no, no, no. The concept of orbit is redundant. It's no more existent. You forget about it. You take an orbital where the probability of finding electron is more than 90% is maximum, bearing a particular energy. Then came the quantum mechanical model of atom. That is the wave mechanical. So when we talk about quantum mechanical model of atom, these are all mathematical. I have cautioned you, please do not think more on real situation inside an atom. It is merely mathematical. So electron is just like a cloud, smeared into a cloud, you just imagine, and it is having wave motion. And at certain point, certain radial distance or at certain angle, as we shall find in our next class, that the probability of finding electron might be equal to 0. তার এপটে আছে electron density, সেপটে আছে electron density, that cloud. Now electron is not a particle, it's a cloud smeared into a cloud. So electron density, even if it is one electron, it is to be thought as a cloud with variable intensity at different radial distance with a different angle that we shall study. So at certain point, this is very funny, that a wave, will have some intensity of electron at certain radial distance, and it will become 0 at certain other radial distance, and again it will have some non-zero intensity at a higher radial distance. How this is possible? It is possible because it is a wave. Because if you think of a wave, this is the crest and this is the baseline. So when it is reaching the baseline, the midpoint, then the intensity, which is known from the amplitude, intensity is more, you are reaching the crest, then intensity goes down and becomes 0, and then it goes again more and more in magnitude, although in the opposite direction. The phase changes in the opposite direction, doesn't matter. এটা যদি উপরে থিলা x axis এর উপরে থিলা, then x axis তଳେ আসিলা, phase change হইগলা, negative আসিগলা, but magnitude again goes on increases till it reaches the trough, and then again it decreases and 0. So that concept of wave can only explain how at certain radial distance the probability of finding electron becomes equal to 0, and that point is called a node. Remember, we'll talk about nodes later. Now see how many derivations I have made. Lambda is equal to h by p. P stands for, you write down you have to write down everything. What I have not written here, you have to write down. So del x into del p is greater than or equal to h by, this we have written. Now see what derivation I have made here. Since from the de Broglie equation, this is de Broglie equation, lambda is equal to h by mv or p. This is de Broglie equation, or p is equal to, p is momentum is equal to h by lambda. If you differentiate dp by d lambda, it will be minus h by lambda square. I don't feel like explaining how we have done some basic differential calculus and differential coefficient and also integration. So you know dxn by dx is equal to what? N x to the power n minus 1. हाँ कि नहीं?
Yes, sir.
Again, sir.
So এটা lambda to the power minus 1 ହେଲା ମାନେ so minus ଟା ଆସିଗଲା ପୁଣି minus 2 ହେଇଗଲା ତଳକୁ ଚାଲିଗଲେ lambda square ହେଇଗଲା. And now del p এই small d ଟାକୁ ଯଦି capital del କରିଦବା then ଏଇ delta lambda ଟା ସେପଟକୁ ପଳେଇଲା in the form of capital delta. So ମୁଁ ସେପଟକୁ ନେଇଗଲି and I only take the magnitude, I forget about the sign, negative टाକୁ भूलिगली sign. And hoop कହୁची कौन del x into del p is more than equal to h by 4 pi. So del x रहिला del p जगह लिखली h by lambda square into del lambda. So that h कटिगला lambda square गोटे सेपटକୁ चलीगला. So there are two other conjugates. Now we find from the same del x and del p टाको हटे दी हमें del lambda कर देले. So the error in position measurement multiplied by the error in the wavelength measurement, wavelength of the electron is a wave. It is having some lambda. We can calculate using the de Broglie equation. So that product will be more than equal to lambda square by 4 pi. So remember, this is a question which came in IIT Advanced. So I put it in my file. And this is energy time uncertainty because I am nearing my. So that means this is the other conjugate variable. It means if an electron spends time, the del t refers to the time it spends in an excited state. I told you that of an electron in the ground state, the closest, what Bismay asked, the closest approach of an electron in any atom is the K cell, the first cell. That which is really, discussed about is the Rutherford's gold foil experiment. To what extent alpha particle can come nearer to the nucleus of the gold atom, after which it will return. Piche mood te chal. We talked about that in the last class. Now del E is the measurement, the error in energy measurement, and del T is the measurement, the error in time measurement. That means when it goes to the excited state, it spends some time. So that time is considered as the error in time measurement. And delta E is the error in energy measurement. If del T is infinitely large, tends to infinity, means infinitely large, then del E will be 0. So the energy measurement will be precise of an electron at a particular orbit. The energy measurement will be precise. If it is precise, then del T will be infinitely large. That corresponds to the stationary state, for example, K cell of hydrogen atom, where we will calculate after some time that del E will be very, very close to 0. So if error is 0, then it is the energy which is known, which is to be accepted with almost all accuracy. That is called the stationary state. We will solve problems. I'm just stopping now for a moment. And those who are watching the video from YouTube, just don't go away anywhere. Of course, you cannot know. You cannot know because I'll be stopping the recording. So, no, you continue. Hello and welcome back. And I had given one numerical to solve. Let me read out the uncertainty in position del x of a moving electron was found to be 1 angstrom, means 10 to the power minus 8 centimeter. Supposing we do it in centimeter. So mass of electron is known, is 9.1 into 10 to the power minus 28 gram. और तुम्हें सेंटीमीटर तुम्हें मीटर रे करछे की
ଆଜ୍ଞା sir,
ଆଜ୍ଞା sir।
ମିଷ୍ଟର।
ओके 10 to minus 10 मीटर कर दउची minus 31 kg कर दउची doesn't matter से कहनी को यूनिट रे दवा पे सेमती किछि रेस्ट्रिक्शन नाही यू कैन यूज एसआई सो del x into m into del v is equal to h by 4 pi you have to take for calculation. It may be more, but calculation ପାଇଁ ଏଟା ନବାକୁ ପଡ଼ିବ. So del x is 10 to the minus 10 into mass of electron is fixed also into del v. H is 6.626 into 10 to the minus 34. I'm not writing the units because all are SI. So whatever del v you will get in meter per second. केते बारला?
sir 1.15 into 10 to the power 6
ଏତିକି ବାହାରିଲା ସ୍ୱୟଂ?
ନାଇଁ sir।
କେତେ ବାହାରିଲା?
Sir 5.797 into
Yes.
10 to the power 5।
Yes, मोर भी सही आंसर बाहरची देखो 5.79 तमे देखिबो टिके कोठी तमे भूल कलर टिके देखिबो ना ना एटा सेंटीमीटर पर सेकंड रे सॉरी ता माने मीटर पर सेकंड रे 10 to the 5 बाहरथिबो
ଆଜ୍ଞା sir 5 ବାହାରିଛି।
ताल ठीक अछि तमर जो 6 बाहरला एटा पूरा भूल हे गला something is seriously wrong in your calculation Mr. Tripathi so it will be 5 point केते कहलो
Sir 797।
into 10 to the power 5 नहीं
ଆଜ୍ଞା sir।
so it's very large. If del x is so small in the level of angstrom, 1 angstrom, so del v becomes very large. Error is very large. Actual velocity too, ଏତିକି ଅଧିକା ହେଇପାରେ ଏତିକି ଅଧିକା maximum ଅଧିକା ହେଇପାରେ ଏଇଟା velocity of electron ଏଇ range ରେ ଆସିବ जो formula 2.18 into z by n जो formula दिया ହେଇଛି ଏତିକି angstrom velocity कहूची हाँ velocity ଏତିକି मीटर पर सेकेंड जो दिया ହେଇଛି 2.18 into 10 to the power 6 तो ସେଇ ପାଖାପାଖି ଏଇଟା ଅଛି so error ଟା velocity ପାଖାପାଖି ମାନେ the error is same magnitude wise more or less same as ये that means after hitting तार velocity double ପାଖାପାଖି ହେଇଯିବ ହବା କଥା ଏତିକି କିନ୍ତୁ ତାର double ହେଇଯିବ so the error has become very profound is large as much as its own velocity so that should be your concept so ଆଉ କେତେଗୁଡ଼ାକ ଅଛି problem that you will be solving at home will be saving time ଏଇଟା ଗୋଟେ ଅଛି ଏଇଟା ଗୋଟେ ନ ଦେଖିକିରି କରିବ ଏଇଟା ତ answer ଏଇଟା ସେଇଟା ଏଇଟା the velocity of an electron in the third cell of H atom you have to find out what is the velocity in the third cell using the same relation that I was just talking about in meter per second. So del V is 99% accuracy means 0.01% inaccuracy. So take 0.01 as the inaccuracy percent. So 0.01, if it is 99 then it is 1%. 1% means divided by 100 is 0.01. That's fraction. So the del V is 0.01 times the actual velocity. So you find del V now. Use hoop to find what is the uncertainty in position. Convert it to angstrom. You will find this one. So a cricket ball having mass 160 gram who was bowled by Bumrah at a speed of 150 km per hour. So tar bahariba angstrom 10 to the power negative 20 angstrom. So both position and velocity can be measured precisely. Small way, small title like ये भी small. Del P is small in the order of 10 to the minus 6. And del X is also small, 10 to the minus 20 angstrom. So it is the tends to 0. So both can be measured accurately. So hope ho ki de Broglie matter wave concept, they are not applicable for macroscopic particles. এটা নিজে করদব মই ফাইলটা পঠাইবি কিন্তু ইলেক্ট্রন পাই যদি ক্রিকেট বল জায়গায় জস্ট ইলেক্ট্রনর মাস নেই যাব তার del x বাহারিব ভেলোসিটি একা দব ভেলোসিটি সেই 150 কিলোমিটার পর আওয়ার জানিকি রখিব যদিও প্রকৃতির ଅଧିକା সেতিকিরে রখিବାକୁ ବୋଧେ ମୁଁ କହିଛି ନା କ'ଣ ଏଇଠି ଅଙ୍କରେ କହିଛି ଲେଟ୍ ଦି ଇଲେକ୍ଟ୍ରନ୍ ମୁଭିଂ ସେମ୍ ସ୍ପିଡ୍ ୟେସ୍ ସେଥିରେ ମଧ୍ୟ ବି 1.393 ମିଟର ବାହାରିଲାଣି del x କେତେ ଲାର୍ଜ ହେଲାଣି ମିଟର ଡେଲ୍ଟା ଏକ୍ସଟା ଏତେ ମିଟର this is not so therefore hoop is applicable for electron গোটাକୁ ଯଦି accurately ବାହାର କରିବ -5 ରେଞ୍ଜରେ ଅଛି ତେଣୁ ଆରଟା become infinitely large I mean ଏତିକି ମିଟର ମାନେ କ'ଣ ବହୁତ ଲାର୍ଜ and ହଁ ଏଇ କଥାଟା ପଚାରୁଥିଲି how to usually ଏଇଟାକୁ କୋଉଠି ତମେ ପାଇବନି rarely ତମେ ପାଇବ how to apply the hoop for the other canonically conjugate variables E and T delta E and delta T their product will be equal to h by 4 pi କ'ଣ ହୁଏ ନା ଯେତେବେଳେ ଏକ୍ସାଇଟେଡ୍ ଷ୍ଟେଟ୍କୁ ଗୋଟେ ଇଲେକ୍ଟ୍ରନ୍ ଯିବ ସେ ପୁଣି ଫେରିବ କେତେ ସମୟ ରହିବ ସାଙ୍ଗେ ସାଙ୍ଗେ ଫେରିବା କଥା ସେ ଯେଉଁ ଏରରଟା calculate the width of the spectral line actually spectral line ଆମେ ଭାବୁ ମନେ ମନେ ଆଗରୁ ଯେଉଁ କନସେପ୍ଟ ମୁଁ ଦେଇଛି ଗୋଟେ ଗୋଟେ ସିଙ୍ଗଲ ଲାଇନ୍ ହବା କଥା ଗୋଟିଏ ମନୋକ୍ରୋମାଟିକ୍ ରେଡିଏସନ୍ ଫୋଟନ୍ ପଡ଼ୁଛି ମାନେ ଗୋଟେ ଲାଇନ୍ ଦେବା କଥା କିନ୍ତୁ ପ୍ରକୃତିରେ ସେଟା ଗୋଟେ ବ୍ରଡ୍ ଗୋଟେ कर्व with a maximum point से ये जो ब्रेड्थ अच्छी आसिला ये जो तले जो ये जो एतिकी जो एटा एरर हवा कथा एक्चुअली कौन पाई से सांगे सांगे आसुनी कैलकुलेट द विड्थ ऑफ द स्पेक्ट्रल लाइन ये जो स्पेक्ट्रल लाइन विड्थ हैला resulting when an atom in an excited state having lifetime तार lifetime हो एतिकी एतिकी पर एतिकी 10 माने very very small 10 to the minus 10 second returns back to the ground state so delta t टाकू सेतिकी नबाक पड़ियो देखो delta t आम जो delta न्यू बार कैलकुलेशन करूछु del e जगह आम लिखिलु hc delta न्यू बार del अच्छी माने कोटा गोटे del लिखे पड़ियो c is constant h is constant so the variable is now the wave number delta न्यू बार into delta t h by 4 pi so delta न्यू बार आसिला so this एटिकी पळे आसला आमे c टा नेले 3 एटा मु सेंटीमीटर पर सेकंड रे नेली 3 टा 4 pi and 8 नेली 10 to the minus 10 सेकंड এই जो समय रहिला संगे संगे न आसिकरी सेटा ताकू ही कहती एरर इन टाइम मेजरमेंट सेटा को पकेली डेल्टा टी जगह रे पकेली एटा से लिखा नहीं एरर इन टाइम मेजरमेंट लिखा जाएनी सो जेति की टाइम से कटेइबो एक्साइटेड स्टेट रे ताकू ही कहती एरर इन टाइम मेजरमेंट पकेले बाहरला केते ना एतिकी सेंटीमीटर इनवर्स आई मीन दिस इज अ ग्राफ ऑफ न्यू बार वर्सेस इंटेंसिटी इन द स्पेक्ट्रम सो जो न्यू बार जो एक्स एक्सिस अच्छी सी कि गोटे गोटे सिंगल आसलानी कि तार गोटे विड्थ आसला यहाँ हूँ एरर एरर इन एनर्जी मेजरमेंट एनर्जी सूचक हूँ वेव नंबर एनर्जी सूचक आम नहींचे सूचक हो पारे इंडिकेटर हो पारे न्यू लैम्बडा न्यू बार जहाँ भी तुम नहीं पार आम नहीं न्यू बार यूजुअली नि जाए न्यू बार सो देयर इज ए विड्थ गोटे सिंगल लाइन हेले डेल्टा न्यू बार जीरो आसता एक्जाक्टली जीरो आसुनी सो देयर इज डेफिनेटली सम एरर इन एनर्जी मेजरमेंट देयरफॉर instead of getting a single line you are getting a broadened graph I mean a peak it is called a peak and the breadth of the peak at the bottom is that peak width the peak width this is called the peak width now assignment is given you will do and answers are given so ei file ta ko pathai dele au se kandiboni ki amaro choto pilata achi to स्वयं से कांदीबनी हाँ डाउट है बुझी न पारे डेफिनेटली you will ask me. ମୁଁ ସମୟ ଦେଖିକିରି କରିବି. Now we shall be just introducing hoop. A hoop କହୁଛି ମୁଁ Schrodinger's wave equation. Now ତମେ ଲେଖିଦେବ ଯୋଉ ଯାକେ ମୁଁ ଲେଖୁନି କାରଣ ଟୁ ସେଭ୍ ଟାଇମ୍ ଆଉ 10 ମିନିଟ୍ 6:30ରେ ମ୍ୟାକ୍ସ ପଳେଇବା. ୱେଭ୍ ଇକ୍ୱେସନ୍ ସେଠୁ ସ୍କ୍ରୋଡିଞ୍ଜର କ'ଣ କଲେ ଡିରାକ୍ ସ୍କ୍ରୋଡିଞ୍ଜର କେତେ ଲୋକ ଆସିଗଲେ ହାଇଜେନବର୍ଗ ପରେ ପରେ ଯେତେବେଳେ ସେ ଅର୍ବିଟାଲ କନସେପ୍ଟଟା ଦେଇଦେଲେ ସେ ଇଲେକ୍ଟ୍ରନ୍ ଯେଉଁ ୱେଭ୍ ହେଲା ଡି ବ୍ରଗ୍ଲି କହିଲେ ୱେଭ୍ ଆଣ୍ଡ ଇଏ କହିଲେ ନାହିଁ ଇଟ୍ ଇଜ୍ ଏ ଇଲେକ୍ଟ୍ରନ୍ କ୍ଲାଉଡ୍ ଶୋଇଂ ୱେଭ୍ ମୋସନ୍. ସେ ତା ପାଇଁ ଗୋଟେ ଇକ୍ୱେସନ୍ ଦେଲେ ତାକୁ କହନ୍ତି ୱେଭ୍ ଇକ୍ୱେସନ୍ ଇଲେକ୍ଟ୍ରନ୍ ୱେଭ୍ ଇକ୍ୱେସନ୍. That was given by Schrodinger for the first time. So it is called Schrodinger's wave equation for electron in hydrogen atom. Hydrogen or hydrogen-like atom containing one electron. ସେଥିରୁ ତାର ସଲ୍ୟୁସନରୁ 3ଟା କ୍ୱାଣ୍ଟମ୍ ନମ୍ବର ବାହାରିଲା. ଗୋଟେ ପ୍ରିନ୍ସିପାଲ କ୍ୱାଣ୍ଟମ୍ ନମ୍ବର ଯାହା ବିଷୟରେ ଜାଣିଛ n is equal to 1 ହେଲେ ଫର୍ଷ୍ଟ ସେଲ୍ 2 ହେଲେ ସେକେଣ୍ଡ ସେଲ୍ 3 ହେଲେ. ଆଉ ଗୋଟେ ବାହାରିଲା क्वांटम नंबर ताको कहती azimuthal quantum number or orbital quantum number or also called angular momentum quantum number. ता विषय डिटेल डिस्कशन करबा नेक्स्ट टाइम. आ गोटे क्वांटम नंबर बाहरला मैग्नेटिक क्वांटम नंबर m. सो गोटे इलेक्ट्रॉन रो एनर्जी प्रिसाइजली तार पोजीशन एंड एनर्जी वेलोसिटी एवरीथिंग को एकदम प्रिसाइजली तो करि होबनी मोर और लेस प्रिसाइजली डिटरमिन करियो को हेले फर्स्ट तीनटा क्वांटम नंबर दरकार. खाली एन जानले हबनी को सेल रे को सब सेल रे अछि. एल विल टेल इन व्हिच सब सेल ऑफ द सेल इट इज देयर एंड सब सेल भितर पुनी ऑर्बिटल अछि. तो अल्टीमेट डेस्टिनेशन रूम जो रूम रे इलेक्ट्रॉन रहे द अल्टीमेट रूम इन व्हिच इलेक्ट्रॉन स्टेज इज ऑर्बिटल m. परवर्ती काल रे स्पेक्ट्रोस्कोपिक स्टडी रू आउ गोटे क्वांटम नंबर बाहरला एस स्पिन क्वांटम नंबर जे इलेक्ट्रॉन निजर अक्ष चारिपटे इट कैन स्पिन क्लॉकवाइज और एंटी क्लॉकवाइज अबाउट इट्स ओन एक्सिस. सेटा स्क्रोडिंजर्स वेव इक्वेशन रू बाहर नहीं सेटा स्पेक्ट्रोस्कोपिक स्टडीज रू बाहर. आरथरक मते मने पकेइबो विस्मय स्वयं जे प्रथमे आमे डिस्कस करिबा what are the demerits of Bohr's model for which quantum mechanics came into existence. Kaiki it was ushered in. What were the failures of Bohr's model that we know, but we will list out. Seta tike ame karine. Seta important that there are 3 point बहुत important. Not only one failure that you know it is applicable for one electron species, hydrogen or hydrogen-like species, not applicable for poly-electron species. Helium atom, helium spectrum पाई applicable हुए, helium plus spectrum. Lithium पाई नुहे कि lithium plus पाई नुहे, lithium double plus. So सेटा तार उटे बड्डा ये परवर्ती काल रे सेटा अन्य लोक माने आसी कि ताकू ये खले सॉल्व खले. किंतु बोर थ्योरी रो सेटा गोटे बड़ आउ ता छड़ा मु एठी कहि दोची काहे कि बेकार समय जेतेबेले देखागला गोटे मैग्नेटिक फील्ड किंबा इलेक्ट्रिक फील्ड अंडर रे स्पेक्ट्रम निगला हाइड्रोजन गैस जो ट्यूब टाकू गोटे बड़ मैग्नेटिक फील्ड अंडर रे रखागला. देन ता दर जो बाहर ग्लो जो लाइट बाहर ताकू प्रिज्म रे पकाई बाल्मर सीरीज निगला कि जेकोसी लाइनमैन पास देखागला जे गोटे लाइन आ गोटे लाइन है कि नाई इट इज स्प्लिट इनटू मल्टीपल लाइन्स कार 3टा कार केतेबेले 5टा केतेबेले 2टा एमती मल्टीपल लाइन्स को स्प्लिट कर जाउछ when the spectrum was taken in the presence of external magnetic field. ताकू कहते G-man effect. आउ इलेक्ट्रिक फील्ड जदि रहबो से एका सिचुएशन आसला किंतु जेतु ताकू स्टार्क बाहर करथिले से इफेक्ट ना होची स्टार्क इफेक्ट. So G-man effect and stark effect could not be explained by the Bohr's theory. The splitting of a single spectral line, peak what I aji कहली line, spectral line into a multiplate. More than one line को कहती multiplate, duplet, triplet, quartet. तो गोटे लाइन जोटा आसूला बोर स्पेक्ट्रम रे एक्चुअली परवर्ती काल रे देखागला से बोर थिले भी जे मैग्नेटिक फील्ड सहित जो मेजरमेंट कराला से गोटे लाइन जोटा आसला ता जगह 2-3टा लाइन कि 5टा लाइन एमती आसला तार डिटेल जीमैन इफेक्ट मु कहे पिला को एडवांस्ड सेटा अछि मोर लास्ट तार ये भी करिछि मोर वीडियो भी आगुरु भी अछि जीमैन इफेक्ट एंड स्टार्क इफेक्ट कुड नॉट बी एक्सप्लेन ता छड़ा जेहेतु इलेक्ट्रॉन टा एक्चुअली क्लॉकवाइज स्पिन करि परिबो एंटी क्लॉकवाइज भी स्पिन करि परिबो तेणु जेतेबेले एट द टाइम ऑफ बोर द स्पेक्ट्रोमीटर वाज वेरी low power spectrometer. It was not able to resolve the lines. ଯେତେବେଳେ ଆସ୍ତେ ଆସ୍ତେ ସୁପର ମ୍ୟାଗ୍ନେଟ ଆସିଲା ସୁପର କଣ୍ଡକ୍ଟିଂ ମ୍ୟାଗ୍ନେଟ ସୁପର କଣ୍ଡକ୍ଟିଭିଟି ଆରମ୍ଭ ହେଲା so the spectrometers were having high resolving power. The resolving power became high. So when spectrometers of high resolving power ଆସିଗଲା 1930s ବେଳକୁ ଆସିଗଲା ସେତେବେଳେ ଦେଖାଗଲା each line was split into two lines, a doublet, two lines. I'm not talking about multiplet, you know, Zeeman effect is different. केवल तीन टाके पांचटा सेटा एक्सटर्नल मैग्नेटिक फील्ड बा इलेक्ट्रिक फील्ड द्वारा किंतु एक्सटर्नल मैग्नेटिक फील्ड इलेक्ट्रिक फील्ड दरकार नहीं खाली सेम थी जो स्पेक्ट्रोमीटर जो प्रिज्म टा नौच आरंभ होला स्पेक्ट्रोमीटर रहउची प्रिज्म टू सेटा पूरा सिंपल वे रे खाली कहिछि किंतु ता भितर बहुत जिंस अछि ये कर स्प्लिट करिया पे स्प्लिट करिया को डिस्पर्स करिया पे एंड ताकू ये करिया पे कोन यू नो तार रिजॉल्व भांगिबा रिजॉल्विंग पावर को बढ़ाया पे बहुत इंस्ट्रूमेंट रो टेक्निक अछि सेटा तळे पावर टा बढ़ा हला देखा गला गुटे सिंगल लाइन टा दीटा लाइन फाइनर लाइंस रे परिणत हे गला प्रत्येक लाइन इनटू टू फाइनर लाइंस कॉल्ड डबलेट बिकॉज इलेक्ट्रॉन स्पिन करूची गोटे क्लॉकवाइज गोटे एंटी क्लॉकवाइज रो गोटे एनर्जी अछि सी जो फेर सी जो ट्रांजिशन एनर्जी विल बी स्लाइटली डिफरेंट फ्रॉम जो सी एंटी क्लॉकवाइज बोलूची सी फेर सो दैट ट्रांजिशन एनर्जी स्लाइटली डिफरेंट हेले दीटा लाइन आसीबो पाखापाखी बहुत पाखापाखी सो ताकू कहते डबलेट दैट कुड नॉट बी एक्सप्लेन्ड बाय सेतेबेले तो जणा नथिला जे गोटे सेल रे सबसेल अछि सबसेल भितरे ऑर्बिटल अछि ऑर्बिटल भितरे पुनी दीटा मैक्सिमम इलेक्ट्रॉन रहि परिबो विथ ऑपोजिट स्पिन गोटे क्लॉकवाइज स्पिन कलन गोटे एंटी क्लॉकवाइज स्पिन करिवो so that their magnetic fields will be cancelled so they can coexist in one room without quarrel. I was telling you. So এই জিনিসটা এইটা হচ্ছে Schrodinger's wave equation. তাহলে দেখি দাও আর্থর আমি লেখিকি টিকে ডিরাইভ করিবা something del square psi by del x square del square psi in 3 dimension by del y square. It is a second order differential equation square achi del square psi by del z square the three coordinates x y z Cartesian coordinates are there is equal to minus 8 pi square m. E is the total energy, v is the kinetic energy, v is the, sorry potential energy. That means it is kinetic energy. E minus v will be kinetic, but we don't take ek. We write always total energy minus potential energy because we will find that the concept of operators will come. Therefore, we need E and V together, not Ek, kinetic energy, no, E, total energy, and V is the potential energy of electron. M is the mass of the electron, H is the Planck's constant, and psi. Psi is called the wave function. That is proportional to the displacement because as the electron is having wave, so its displacement from the mean position is constantly changing to the maximum position called amplitude, then decreasing, then going zero, node is coming, and then it is going in the opposite direction, increasing in magnitude, coming to the crest, and maximum displacement, that is called amplitude again and again. So these variable displacement, they are nothing but that is called the wave function. That is related to wave function, psi. And as I have told you, E is the total energy, V is the potential energy, and so on. And the psi, this wave function is often called the Eisen function. The wave function is often called the Eisen function, which represents an orbital. One psi will represent one orbital, which will be represented by a set of n, l, m. N is equal to 3, l is equal to 0, m is equal to 0, or n is equal to 3, L is equal to 1, L is equal m is equal to -1. So a particular combination, rather I'll say combination of n, L, m will define a wave function, Eisen function, and that will also define an orbital. तार भितरे मैक्सिमम दीटा इलेक्ट्रॉन रहिबो सेटा स्पिन क्वांटम नंबर जोटा एठी स्क्रोडिंजर्स वेव इक्वेशन रु स्पिन क्वांटम नंबर आसेनी s सेटा स्पेक्ट्रोस्कोपिक स्टडीज रु आसे मु जो कहउतली विथ ए हाई रेजोल्यूशन स्पेक्ट्रोमीटर ईच लाइन वाज फाउंड टू बी ए डबलेट सेठु आसे. सो वी विल स्टॉप इट हियर. वी शैल जस्ट आई एम जस्ट मोटा को डेरिवेशन करबी एटा को टिके एपट सपोर्ट करि देले यू नो आको एपट सपोर्ट करिया पूर्वरु साइटा को जदी बाहर कर देबी खाली ऑपरेटरटा नै जिबी del square by del x square plus del square by del y square plus del square by del z square सेटा गोटे को ऑपरेटर कहंती ताको कहंती del square माने रिवर्स del square that is called Laplacian operator. So del square, the reverse del square is called the Laplacian operator, which is nothing but small del square by del x square plus small del square by y. साइटा नहीं साइटा को ऑपरेट करिबा सेतमेई del square into psi ता अर्थ एटा जगह रे ताकू छोटो कर दवा पई आमे ताकू ऑपरेटर कर देले. सो एही ऑपरेटर टा होची इनवर्स del square into psi एपट साइड रे जा थिला से रखिले एईटा को खाली बडटा को छोटो कर देले एवं पुणी एटा को नेई करी जदी एपट सेपट आमे करबा v टा को गोटे पट को आनिबा जानि करी सेति पई तो v रहिला आ ये रहिला एवं ई टा को आर पट को नेई गले देन एई जोटा रही गला psi रो आउट ऑपरेटर हैला. This becomes another big operator for psi wave function, the Eisen function. That big operator is called the Hamiltonian operator H. So H psi is equal to E psi. तेणु करी पिला माने को कहे जे तुमे जे पचारिबो स्क्रोडिंजर इक्वेशन कोन तमे टिके हाई फाई रे आंसर दब H psi is equal to E psi. H means what is H? It's Hamiltonian operator. पचार से कोन ना एटा विराट बड़ गोटे हाथी ऑपरेटर minus h square by 8 pi square m del square by एटा Laplacian operator एटा एतिकी Laplacian जेतरे minus h square by 8 pi square m एपट सपोर्ट कले तम पाई परिबो. सो प्लस v Laplacian operator अछि गोटे potential operator अछि मिसी गले टोटल that whole combination is called the Hamiltonian operator into psi. आमे ऑपरेटर कथा जानिबा जे गोटे फंक्शन को गोटे ऑपरेटर रे ऑपरेट कले जदि सही फंक्शन आसिला with some constant that is e that is a particular kind of operator. आमे कहिबी से विषय आउट के डिटेल मु कहिबी that is a special kind of operator. And so the operator when is operated upon a particular function gives the same function with multiplied by a constant. That E is called the Eisen value, the energy value, the Eisen value. I mean, say that more about Heisenberg principle. Schrodinger's wave equation. Outika besi odika nuhe besi odika moro notes re achi बहुत अधिका माने पूरा होल कैलकुलेशन टा तमरो दरकार नै डेरिवेशन टा सॉरी दरकार नै किंतु आउ टिके मु अधिका मु गोटे फाइल रे पढेबी तापर हमें क्वांटम नंबर्स विषय डिटेल पढिबा. सो एतिकी जगह तुम लिखि देथिबो होपफुली तुम बुझी पारिबो जेतिकी जगह लिखाई छी h psi is equal to e psi तापर हमें क्वांटम नंबर्स सोमवार दिन करबा आज शुक्रवार सोमवार. बाय बाय.
Thank you, sir.
Thank you, sir.
थैंक यू. हे हो एटा मु बंद कर दूची माने एटा को स्टॉप रिकॉर्डिंग हे गला. विस्मय तमे कहीं कि केते जण पिला कि आमे अछु तमे कहीं कि तुम पर्सनल ये रे करूछ. थैंक यू. तुम जानिछ सिंस यू आर एन यूरानियम गाय यू नो जे सब जिंस रे गोटे रेसिप्रोकेशन अछि. आमे गुरु दक्षिणा कौन सी फॉर्म रे आमे दबु गोटे होची ग्रेटिट्यूड मु तुमको सिखौची तुम सब जानिया जानिछ टू शो योर ग्रेटिट्यूड. तमे केमिति जणेबो by saying thank you, by expressing thank you. So that सेटा समस्त आगरे जणेले अन्य माने मोटिवेटेड हेबे जो माने सेबे भाबु चंती जो ना एटा गोटे साधारण जिंस ऐसा अर्थ तांकर काम होची सारकर किछि काम नाही से पढेबे. इट्स नॉट लाइक दैट. न पढ़िले भी सार अन्य अन्य काम अच्छी अन्य अन्य काम अच्छी भी सार बिजी रही पारिबे ଏଇଟା ଗୋଟେ ମାଧ୍ୟମ, ଆଉ ଗୋଟେ ବିଜି ରହିବା ପାଇଁ ବା ମନ ଖୁସି କରିବା ପାଇଁ ଗୋଟେ ମାଧ୍ୟମ, କିନ୍ତୁ ଅନ୍ୟ ବହୁତ ମାଧ୍ୟମ ଅଛି। ତେଣୁ ସେଥିପାଇଁ ତୁମେ ସବୁ କେବେ ଭୁଲିବ ନାହିଁ ଯେ ତୁମେ ୟୁ ହାଭ୍ ଟୁ ଶୋ ୟୋର ଗ୍ରାଟିଚ୍ୟୁଡ ଟୁ ୟୋର ଟିଚର ଅର୍ ଟୁ ଏନିୱାନ୍ ହୁ ଇଜ୍ ହେଲ୍ପିଂ ୟୁ ଅର୍ ହୁ ଇଜ୍ ଗାଇଡିଂ ୟୁ। ସେଇଟା ଗୋଟେ ତୁମର ଶିକ୍ଷା। ଦ୍ୟାଟ୍ ଇଜ୍ ଦ ପ୍ରାଇମେରୀ। ଇଭେନ୍ ପ୍ୟାରେଣ୍ଟସ୍, ତେଣୁ ତମେ ପବ୍ଲିକଲି, ସେ କେତେ ଜଣ ପିଲା ବି ଅଛନ୍ତି ସେଇଠି କାହିଁ ଦଉନ, ତମେ ଲାଜଉଛ କ'ଣ ପାଇଁ? ଲାଜ ମାଡୁଛି କ'ଣ ପାଇଁ? ପବ୍ଲିକଲି ତମେ ତ ପବ୍ଲିକଲି ଗଲେ ଟିଚରଙ୍କର ଇଏ କରୁଛ କ'ଣ, ତାକୁ ପାଦ ଛୁଉଁଛ ବା ଇଏ କରୁଛ, ଯୋଉଟା ମତେ ଭଲ ଲାଗେନି ପାଦ ଛୁଇଁବା। ଏନିୱେ ମୁଁ ତାକୁ କ୍ରିଟିସାଇଜ କରୁନି। ମୁଁ ଚାହେଁ ଆମର ମୁଣ୍ଡକୁ ତଳକୁ କରିକି ପ୍ରଣାମ କରିବା, ଯେମିତି ଆମେ ସମସ୍ତଙ୍କ ଦେହରେ ସେଇ ଦେଖୁଛୁ, ପରମାତ୍ମାକୁ ଦେଖୁଛୁ। ସବୁ ଆତ୍ମା ପରମାତ୍ମା ସାଙ୍ଗରେ ଗୋଟେ ଅଂଶ। So do that. That you will feel better and your teacher will feel better as your duty. Not only duty ଗୋଟେ କରିବା ପାଇଁ କରିବା, no, feeling should come from within. ଏଠି ଗୋଟେ ଲୋକ ସକାଳୁ ଆସୁଛି and we will not show any kind of our reciprocation, gratitude, କିଛି ନାହିଁ. That's what I'm saying. Make it public and set an example for others. Bye bye.